Assalamualaikum warahmatullahi wabarakatuh. Let me begin with the introduction of our group project. Titration is a quantitative analysis concerned with measuring the volume of a solution with known concentration required to react with the substances to be determined. Well, on this case, alkalimetry method was used. So what is an alkalimetry? An alkalimetry is used to determine the levels of acidic compound that are reacted with essential standard solutions. This alkalimetry is a back titration method in which excess acid is added to the sample to react with the antacid, and the excess acid reacted is titrated using sodium hydroxide with phenolphthalein solution as an indicator. Did you know that technological advancement and modern lifestyle have led to a significant increase in gastrointestinal disorder, with nearly 7,000 Indonesians currently suffering from stomach ulcers? This condition, often caused by irregular eating patterns, stress, and lack of sleep, result in excess stomach acid production that irritates the gastric mucous membrane. So antacids are widely used, cost-effective medications that designed to treat these disorders by neutralizing hydrochloric acid in stomach. The main functions of antacids are increasing the pH of the gastric lumen, reducing the pepsin activities, as well as relieving symptoms such as nausea, bloating, and heartburn.
Assalamualaikum and hi, my name is Ikram. I will be presenting about the theory. The first theory is back titration, which is a titration where the analyte is reacting the known amount of excess reagent. The excess reagent would then be titrated with a second reagent. The second titration was done to find out on how much the excess reagent was used and to calculate the concentration of the original analyte. In this case, antacid is used as the analyte. Is also a weak base, and the first reagent is hydrochloric acid, and the second reagent is sodium hydroxide. For the second theory, the equivalence point and acid-base titration. Acid-base titration is a process of adding amount of standard reagent with known concentration to an analyte until the reaction is complete. The equivalence point is the point where the amount of added titrant or reagent is equal to the amount of the analyte. The endpoint is invisible, and that's why we have to use an indicator to make the endpoint visible. In this case, we use phenolphthalein. It's used for antacid, as antacids are a weak base with a pH range between 8 to 9.6 and will undergo color changes from colorless to pink when reaches the pH range. From the theory, we were able to create chemical equation. The first equation is calcium carbonate reacting with hydrochloric acid to create calcium chloride, water, and carbon dioxide. The calcium carbonate is known as antacid in this case. For the second chemical equation, we have hydrochloric acid reacting with sodium hydroxide to create sodium chloride and water. This is known as bad titration because we are using excess amount of hydrochloric acid and is titrated with sodium hydroxide.
So, how this alkalimetry works? Well, let me tell you. As I mentioned earlier, this alkalimetry works by adding an excess hydrochloric acid to react with the antacids. First, the excess acid reacted, then have been titrated with standard solution, which is sodium hydroxide. Last but not least, obviously we use phenolphthalein as our indicator, which indicates the endpoint through a color changes from colorless to pink that range around 8.0 up to 9.6.
Hello, my name is Irfan and I will now talk about an example of an experiment. For the sample, the antacid tablets from 6 brands were bought from pharmacy shops in Aochi, Nigeria. The tablets were certified by professional pharmacists as up to grade. Each tablet from different brands were also weighed and mass recorded. after which it is crushed finely using a mortar and pestle. The tablets were then transferred into a 250 ml beaker and each were labeled with their brand names. The doses were also jotted down from each brand as to identify the correct dosage. In turn, the results will be compensated for the doses required for each tablet. After that, 50 ml of 0.01 mol of HCl was added into the 250 ml beaker containing the antacid tablets. The mixture was then heated for 15 seconds until the tablets have dissolved into the solution. Then 3 drops of phenolphthalein was added into the solution as an indicator. The excess HCl of 25 ml was then used to determine the amount of acid neutralized by the different antacid tablets. By performing back titration with standardized 0.01 mol of sodium hydroxide until the endpoint of phenolphthalein. And here we have the table of results of each antacid tablets that were tested. Firstly is the weight of the tablet, which is either 1.1 grams or 1.2 grams respectively. Secondly, we have the weight per dose of each tablet, as each recommended doses requires 2 tablets, barring omeprazole, which only requires 1. Then we have the color changes before and after adding HCl and phenolphthalein, as some antacid tablets will have differing compounds which will affect the color. Most importantly, the color of the endpoint for each tablet is shown to be pink, which indicates that the solution has been turned from acidic to base due to the introduction of the sodium hydroxide. After which, we have the litmus paper test before and after the test, which again proves that the solution has been turned from acidic to base. Finally, we have the numerical results, which shows the initial and final burette readings. This shows the amount of sodium hydroxide used in each titration attempt, as the final reading is subtracted by initial reading to show the amount used. However, each attempt has an initial reading of 0, which means that no subtraction is required and that the burette is at full capacity of 50 milliliters. With that, the antacid tablets with the lowest volume of acid neutralized by sodium hydroxide is shown to be more potent. This is due to the acidic nature of HCl, which is mostly neutralized by the antacid tablets, leaving less volume to be neutralized by sodium hydroxide. The antacid neutralizing capacity is then calculated by subtracting the volume of sodium hydroxide used with the volume of acid neutralized by sodium hydroxide. Thus concludes our study on the uses of titration in analyzing the effectiveness of antacid tablets. Based on the results, some brands are proven to be more potent as acids are neutralized more efficiently compared to other brands. This shows that the titration method in the form of back titration can be used to identify the effectiveness of antacid tablets, with some drawbacks being less accuracy and less selectivity compared to other methods such as using a pH meter. However, it is still suitable as a reference for small-scale industries or experiments. My name is Irfan and this is the end of our presentation.